Today we're going to be reading this whole article. It's called Curious Mary Curie. Just be aware that what you're looking at now are actually two pages that should be kind of folded together. Okay, so this is our title page, Curious Marie Curie. And if I look at the image, I mean, look how intense she looks. Look at her eyes. She's obviously got some scientific equipment. She looks intense. She looks focused. She looks serious. So let's learn about Mary Curie. Curious Mary Curie. So that should be page one. Here's page two. There we go. Radiation all around. That's the heading. So I guess radiation all around. We're going to learn about how radiation is kind of all over the place. Ah, summertime. Swimming has made you chilly. So you let the sunlight warm you from head to toe. The sun is extremely distant, yet your skin tingles with heat energy. What's the secret? The warmth you feel is due to radiation. Radiation is the movement of energy from one place to another. Solar radiation is light energy from the sun, which converts to heat energy when it hits your skin, making you feel warm and tingly. But you don't have to travel into space to find other sources of radiation because everything on Earth gives off some radiant energy. In fact, some of these sources radiate enough energy to power entire cities. So radiation is all around us, right? It comes from the sun, the earth itself. Everything on earth, it said, gives off radiant energy or radiation. So let's look at this image. Here's a caption. It says, solar radiation creates heat energy, which warms you up. But solar radiation can also harm your skin. So I guess radiation is both good and bad. Let's move on to page 3. Nuclear power plants use the radiant energy found in atoms of uranium, a natural element found in the ground. This power is called nuclear because the energy comes from the atom's core or nucleus. Uranium has the potential to produce about 2 million times as much energy as oil or coal. That is a lot more energy than oil or coal. In 1897, French physicist Antoine-Henri Becquerel discovered that uranium releases energy. However, another remarkable scientist named Marie Curie figured out how it gives off energy. So this guy figured out that it does give off energy, right? That uranium gives off energy, but Marie Curie figured out how that happened. She would completely change our understanding of atoms. She even discovered two new elements along the way. All right, so this is Antoine-Henri Becquerel. He's got some cool facial hair, nice beard and mustache. Uh, when did he live? 1852 to 1908. And what does this say? There are over 400 nuclear power plants in the world. Did you know an atom of uranium can quickly release an enormous amount of energy and radiation? Some countries have used this power to create nuclear weapons. So radiation comes from everything, but that uranium can produce energy or nuclear weapons. All right, so let's move on to page 4. So now we have a new title, a new heading called Curious Marie. So I guess now we're going to get into Marie Curie. So far, we've just been learning about the background information about nuclear energy and radiation. So let's learn about Marie Curie. So I see some images here. I'm just going to look at those first. So Marie in the middle with her siblings. So I guess this is her when she was little. Marie at Sorbonne University. So I guess when she was in college. And then here is Sorbonne, one of the oldest universities in the world. Dates back to the 13th century. It looks beautiful, huh? Look at these buildings. So, as she's getting older, going to college, let's learn about her. Curious Marie. Born in Poland in 1867, Maria Sklodowska loved science. Well, who is Maria Sklodowska? I thought we were learning about Marie Curie. Although most girls were not allowed to attend school at that time, her parents made sure Maria was educated. Okay, so I guess it's the same person. Maybe she changed her name. Maria's dream was to study science at Sorbonne University in Paris, France. It took hard work and patience to save enough money to go to France. Maria moved to Paris in 1891, changing her name to Marie to fit in. Even though she didn't speak French when she arrived, she graduated from Sorbonne at the top of her class in 1893. Still eager to learn, she continued her education. In 1903, she became the first woman in Europe to earn a PhD, but her science honors had only just begun. Wow, what an amazing woman, huh? Studied college in France without even speaking French and still graduated at the top of her class? All right, but her science honors had only just begun, so I guess she's going to do a whole lot more, huh? All right, page 4 and 5, two new headings. So this one's atoms and energy. So what are we going to learn here? I would assume we're going to learn about atoms and the energy that they give off. That would be a good guess. Marie began working with a physicist named Pierre Curie. A physicist is a type of scientist that studies atoms. They fell in love and married in 1895. 2 years later, Becquerel discovered that uranium emits energy. We already learned that, right? Marie decided to figure out the mystery of how uranium worked. Uranium is found in ore. Well, what is ore? Natural minerals in the ground. So ore are natural minerals in the ground. Marie learned that when greater amounts of uranium were present, an ore sample radiated more energy. So the more uranium, the more energy it radiated out. Marie suggested that the energy must come from inside the uranium atoms themselves. If so, this would mean that atoms must have smaller parts inside that somehow emit or give off energy. So emit means give off. No one had thought of this before, so her hypothesis alone was big science news. Remember, hypothesis is like a scientific guess. So let's look at these text features. Here we have a report. In this report from 1903, Marie announced a key discovery. And then here's Marie and Pierre Curie in their lab. All right, new elements. So what are we going to learn here? I guess about how maybe she discovered some new elements, because I remember it mentioned that before. Next, Curie separated the uranium from the ore, right? So she had those minerals and she took the uranium out of this rock. Surprisingly, she noticed that the ore was still releasing energy. So even though the uranium was out of the ore, it was still giving off energy. She suggested that new elements within the ore could also radiate energy. Marie and Pierre used several tons of ore to collect enough of the new elements to study them. After 4 years of hard work, Marie named two new elements, radium and polonium. Both elements emit far more energy than uranium. Radium is 1 million times more active than uranium. Marie named this newfound form of energy radioactivity. So radioactivity that word was created by Marie Curie after she discovered all these radioactive types of matter. Marie and Pierre shared the 1903 Nobel Prize for their study of radiation. Marie also won the 1911 Nobel Prize for her discovery of radium and polonium. So she won two Nobel Prizes, which is a big deal. Did you know a woman winning a Nobel Prize was unheard of in 1903? In fact, Pierre Curie alone was first offered the Nobel, but he refused to accept it if he could not share the prize with Marie. Still, only Pierre was allowed to deliver the acceptance speech. So here's Marie. She's the first woman to graduate from her college. She wasn't allowed to get the Nobel Prize because she was a woman, yet she still kept working and discovering. What an amazing person. Okay, what's next? Unstable atoms. Just from that title and the picture and what I know about radioactivity, I'm thinking this is going to be about how radioactivity actually works. Maybe. All right, let's see. Unstable atoms. How do uranium, radium, and polonium give off energy? Like all elements, these three are made of atoms. Each atom has a central nucleus made of particles called protons and neutrons. So I guess if I look down here, here's the atom, and all these red and blue particles are your protons and neutrons. A radium nucleus has many more neutrons than protons, making it unbalanced or unstable. To become more balanced or more stable, it sheds or gives off some of the protons and neutrons. Through this process, the atom radiates energy. This is nuclear radiation. So let's look back here. So here's a radium atom, and it looks like it's giving off some particles, some blue and red particles, some neutrons and protons, and I guess it changes form, right? When an element changes its number of protons and releases energy, it becomes a completely different element. This is called radioactive decay. In the case of radium, it becomes radon, a gas. So here's your radium atom. It gives off some of its particles to become more stable, and it changes form into radon, which both of which are radioactive because an element is radioactive if it's giving off these particles. An alpha particle has two protons and two neutrons. When a radium atom decays, it gives off an alpha particle and becomes radon gas. So it's actually giving off some of those particles and changing form into a new type of matter. Okay. Radium is all the rage. What is that about? I mean, radium I know is dangerous because it's radioactive. Why would it be the rage, right? What rage in this case I think means it was popular. It's all the rage. Why would it be popular? Let's find out about that. Around 1900, nobody knew that radioactivity could harm people. In fact, radium was thought to have healing qualities. This new wonder element glowed in the dark and gave off heat. Well, that's pretty cool. Toothpaste, drink mixes, and even chocolate containing radium were produced until the mid 1900s. Can you imagine? Radioactive elements in your toothpaste, in your drinks, in your chocolate? Popular products emerged with names like Radium Brand Creamery Butter and Tho Radia. There was even a dance called the Radium Dance. So can you imagine this is like the most popular thing right now? Radium is all the rage. Everyone's talking about it. Everyone wants it. They're putting it in everything. They don't really know what it's about. Because radium paint glowed in the dark, companies applied it to airplane dials, clocks, and wristwatches. The numbers glowed in the dark. Very cool. But a much darker side of radium would soon be discovered. I like that transition, right? Because this section is all about how radium was great. It glows in the dark. They put it in everything. Everyone loves it. But a much darker side would soon be discovered. I'm thinking that means in the next section it's going to be about, maybe how radium was not so great. Just a thought. Let's look at this next feature. We've got some cool looking stuff down here. What is this? Drinks made with radium and wristwatches with glowing radium numbers were popular until the mid 1900s. Spa radium looks nice until you get radiation poisoning. Let's see. Radium's legacy. So a legacy is kind of like what it's remembered for or what impact it has. So let's see. Today we know that large doses of radiation can damage the human body. In clock factories, thousands of "radium girls" use their mouths to shape the tips of paintbrushes covered with radioactive paint. Many later died from bone disease. That's horrible. So I guess why would they use their mouths to shape the tips of the paintbrushes? I guess they were, you know, trying to make it sharper. Because if you can imagine painting numbers on a watch, they'd be really small, right? So I guess they had to shape the tips to make them sharp. Little did they know that that radioactive paint was deadly. Radium girls were exposed to harmful radiation daily. Mary Curie herself handled radioactive elements for decades without any protection. She died at age 67 from a bone disease that was probably caused by radiation. It was her life's work, but ultimately, she gave her life to her work. Thanks to Mary Curie, we understand radioactivity. She overcame many challenges to follow her passion and was able to light up the world with the power of knowledge. Great. What is this? Wowzer. Geiger counters detect radioactivity. Scientists used one of these machines to examine the Curie's notebook. They're still too radioactive to be handled today. All right, so I hope you learned some about Marie Curie and radiation. You will be looking at smaller parts of this article in the next few days and looking for details. So, but now at least you've heard the article. You can listen to it again anytime you want, and make sure you go into the classwork section. There are some questions for you to answer about what you learned.